percent of those atoms would be the magnesium-24. So that would be the most common, right? Do you see that? Now there may be 78 one time, there may be 79 at another count. But statistically you will have around 79% of the atoms to be magnesium-24. You would have 10% of the atoms to be magnesium-25. Now you guys know me, a lot of times I just make up problems off the top of my head, but here you can't. You kind of have to have a book that's got a worked out problem, or you have to have a computer that tells you the answer. I mean, who the hell knows what the real answer is, right? And then you would have the magnesium-26 would be 11.01%. So you can see the most common isotope is the magnesium-24. The second most common is the magnesium-26, followed by the magnesium-25 in that order. Now the whole percentage has to add up to be what? That must add up to be 100. Okay? So again, 100 atoms, about 11 of them would be this one, about 10 of them would be that one, and about 79 of them would be that one. Now, let's see how much these things weigh. The first one weighs 23.985 atomic mass units. Now, you see that that's not exactly 24, right? But do you admit that it's close? So why is it that that number is off just a smidge? All right. And there's a couple of reasons for that. One of the reasons is what's called a relativistic effect. In other words, the forces that hold protons and neutrons and that together, all right, have so much energy that can be translated into mass that sometimes this number goes down just a smidge. All right. Now let's look at this one here. The magnesium-25 weighs 24.986 AMU, and the magnesium-26 weighs 25.983 AMU. So this is all data that had to have been given to you. You cannot give birth to this, right? It's measured on this little tool right here called a mass spectrometer. All right. And what this does is this is a mass on the bottom, and this is an intensity or a percent up through here. So what's the most common? The magnesium-24. What's the second most common? The magnesium-26. You see how that peak is just a sniff higher than that peak? All right, and then of course the magnesium-25. So that's how it's measured. Okay. Now, if you were doing chemistry, are you doing chemistry on one atom or a whole bunch of atoms? What's that? A whole bunch of atoms. So you have to take an average. In other words, if you had a whole bunch of atoms of magnesium in your hand right here, you would not just be performing chemistry on the number 24 atom. Okay? You would be performing chemistry on all these atoms statistically. So how much do they statistically weigh? Well, look in your book. 24.305 or 30 something like that. What's your book say? 24.31 is what your book says. So how do they get that number? They average them all up. Now the number one mistake is don't do this. Do not add these three numbers up and divide by 3. If you did that, this would have been 33.33%, 33.33%, and 33.33%. Is that cool? That's not cool, because that's not what that is. As a matter of fact, let's just go ahead and do it for giggles. Okay, 23.985 plus 24.986 plus 25.983 equals, divided by 3, what do you get? 24 point what? 98 or 25? Now is that 24.301? No. 25 is not 24.301. I mean 305. All right. So, how do you get it? Well, you have to do a weighted average. Bridget, can we see this? 78, wait a minute, let's do it the other way. What's that now? When I move aside, okay. Here's what we got. We got 23.985 times 0.7899 plus, oh, what am I doing? Okay, here's what I'm doing. I'm moving the percents to a decimal value. You see that up there? So in other words, I'm taking my 78% and I'm moving it 2 places over. So looking at this data here, what will the mass be closest to? 24, 25, or 26? Well, you already know the answer. What's the mass closest to? 24. That makes sense, right? Look at the percentage. It's huge. This would be like, right, if you would ever take a stupid class like this, but you would have a syllabus. And the syllabus says on the first test will be worth 78.99% of your grade. Now, would that not be stupid? Right? The second test would be worth 10% of your grade, and the third test would be worth 11% of your grade. When are you going to do your most studying? At first test. Because this right here will make or break the deal. Your average, whatever you get here, and if it's a 23.9, that's what your average will be the closest to. If your average on that first test was a 100, no matter how you did on these tests, your average would be closer to the 100 than any of the other numbers. Does that make sense to you? Okay, so that's how we got to average that. All right, so here we go. 24.986 times 0.1. They probably love it when I whistle into the daggone microphone. And then 25.983 times 0.1101. All right, somebody whip that out in your calculator and tell me what you're getting. Now remember, here we have multiplication and addition, so do not forget the parentheses or forget your orders of operation. Multiplication has to be done first before you hit those plus buttons. Has anybody got a number yet? 24.305 AMU. Now what did the periodic table say, 24.31 in your textbook? So did we get the same answer? Sure we did, and we should. So on the test with these type of problems, you know the right answer. You got the periodic table in front of you. All you got to do is match it. Now, you do have to show work, right? Naturally, you just can't write down 24.31, and I just assume that you know how to figure this out. All right? Are we good? Should we do another one? Yes, no? One more? Let me pick one there that's not... let me see if we can do argon. The only problem is the fingerprint for argon is probably huge, as if my memory serves me correctly. We don't sit here all day. No, it's not. It's got 3. All right. So here's what we're going to do. We'll stop the camera. Okay. You guys, pardon me.